Learning objectives. At the end of this topic, you will be able to describe volume of cube, cuboid and cylinder. Welcome to the topic volume of a cube, cuboid and a cylinder. First, let's define volume. Amount of space occupied by a three-dimensional object is called its volume. Let's consider the first water bottle holds 240 ml of water. So the volume of the liquid is 240 ml. The second water bottle holds 130 ml of water. So the volume of liquid is 130 ml. The third water bottle holds 60 ml of water. So the volume of the liquid is 60 ml. Now we can discuss about capacity. Capacity, defined as amount of space occupied by a three-dimensional object, is called its volume. For example, the capacity of the bottle is 500 ml. Now let's learn about the volume of a cuboid. The volume of the cuboid is equal to the product of its dimensions. That is, length into breadth into height, cubic units. Find the volume of the cuboid whose dimensions are given as length is equal to 3 cm, breadth is equal to 4 cm, height is equal to 2 cm. Therefore, the volume of the cuboid is equal to 3 into 4 into 2. That is equal to 24 cubic centimeters. Volume of a cube. In a cube, all the 6 sides are equal and all the 3 dimensions are equal. Let side of a cube be equal to A units. Therefore, volume of a cube is equal to A into A into A, which is equal to A cube cubic units. Find the volume of a cube whose side is 6.5 centimeter. Let this side be equal to A, equal to 6.5 centimeter. Volume is equal to A cube cubic units, is equal to 6.5 whole cubed, is equal to 274.625 cubic centimeter. It's equal to 274.63 cubic centimeter, rounding up to 2 decimal places. Volume of a cylinder. Let the height of the cylinder be equal to h units. Let the base radius of the cylinder be equal to r units. Therefore, volume of the cylinder is equal to base area into h cubic units. Here, base area is equal to area of the circle is equal to pi r squared. Hence, volume of the cylinder is equal to pi r squared h cubic units. Find the volume of the cylinder whose base radius is equal to 7 centimeter and height is equal to 12 centimeter. Use pi is equal to 22 by 7. Substitute the values in this formula. We get volume is equal to 22 by 7 into 7 into 7 into 12 is equal to 22 into 7 into 12, which is equal to 1848 cubic centimeter. Therefore, volume is equal to 1848 cubic centimeters. A milk tank is in the form of a cylinder whose radius is 1.5 meter and length is 7 meters. Find the quantity of milk in liters that can be stored in the tank. Let radius of the milk tank be equal to r is equal to 1.5 meter. Let length of the milk tank be equal to 7 meters. Capacity of the tank is equal to pi r squared h cubic units. Therefore, capacity of the tank is equal to 22 by 7 into 1.5 into 1.5 into 7 is equal to 22 into 1.5 into 1.5. Multiplying these 3 numbers, we get the capacity of the tank, which is equal to 49.5 cubic meters. 1 cubic meter is equal to 1000 liters. Hence, 49.5 cubic meter is equal to 49.5 into 1000 liters. Therefore, capacity of the tank in liters is equal to 49,500 liters. The diagram shows a stage stairs made up of a wooden cube and a cuboid. Find the volume of the stairs in cubic centimeters. How do we find the volume of the stairs? What do we need to know first? Yes, we need to know the volume of each 3D shape that forms the stairs. Only then we can calculate the total volume of this 3D composite shape. Let us begin by finding the volume of the cube first. What is the volume of the cube? The volume of the cube is the amount of space that it takes up. To calculate the volume of the cube, we need to know the length, the height, and the breadth of the cube. Let us label the length, the height, and the breadth of the cube. Given that the length of the cube is half the length of the cuboid, so halving 100 centimeters gives 50 centimeters. The length of the cube is 50 centimeters. A cube has equal dimensions. This means the length, the breadth, and the height of the cube are equal. Now calculate the volume of the cube. Multiplying 50 centimeters into 50 centimeters into 50 centimeters equals 125,000 cubic centimeters. How about the volume of this cuboid? A cuboid has different dimensions in length, breadth, and height. Let us label this cuboid. Its length is 100 centimeters. The breadth is 50 centimeters and its height is 50 centimeters. The formula to find the volume of the cuboid is same as the formula to find the volume of a cube. We multiply its length by its breadth and its height. 100 centimeters into 50 centimeters into 50 centimeters. We get 250,000 cubic centimeters. From the information we have here, what do we need to know to find the volume of this 3D composite shape? Good. We add all the volumes of each shape. Adding 125,000 cubic centimeters with 250,000 cubic centimeters equals 375,000 cubic centimeters. See, the volume of the stairs is 375,000 cubic centimeters. The diagram shows a monument built to commemorate the celebration of the 50th anniversary of a company. Find the volume of cement used to build the monument in cubic meters. How do we find the volume of cement used to build the monument? What are the shapes that form this 3D composite shape? Good. A cube and a cuboid. Let's begin by finding the volume of the cube first. What is the length, the breadth, and the height of the cube? Good. The cube has equal dimensions. So it is 2 meters into 2 meters into 2 meters equals 8 cubic meters. How about the volume of the cuboid? Its length is 4 meters. Its breadth is 5 meters and its height is 1 meter. So multiplying 4 meters by 5 meters by 1 meter, we get 20 cubic meters. Now what do we need to do next? Yes, add these two volumes to find the total volume of the 3D composite shape. 8 cubic meters plus 20 cubic meters equals 28 cubic meters. So the volume of cement used to build the monument is 28 cubic meters. Let us look at a problem again. Bhaskar has prepared 3 molds to build a bench. How much cement does he need to be filled into the molds? What is the volume of cement needed to build the bench? What do we need to find first? Good. We need to find the volume of the molds first. Let's begin by finding the volume of the cube-shaped mold first. This cube measures 30 cm in length, 30 cm in breadth, and 30 cm in height. Multiply 30 cm by 30 cm by 30 cm. We get 27,000 cubic centimeters. There are two identical cube-shaped molds. So the volume of the two cube-shaped molds is 2 times 27,000 cubic centimeters. Do you get 54,000 cubic centimeters? Good. What do we need to do next? Yes, we find the volume of the cuboid-shaped mold. The cuboid-shaped mold measures 120 centimeters in length, 30 centimeters in breadth, and 10 centimeters in height. So, 120 centimeters into 30 centimeters into 10 centimeters equals 36,000 cubic centimeters. Now from this information, what do we need to do to find the volume of the cement needed to build the bench? Good. We add them. Adding 54,000 cubic centimeters with 36,000 cubic centimeters, we get 90,000 cubic centimeters. Bhaskar needs 90,000 cubic centimeters of cement to build the bench. On the table shown is a chocolate cake made by Asha. She plans to give the chocolate cake to her classmates. There are 30 pupils in Asha's class. Asha plans to cut the cake into smaller pieces measuring 5 centimeters by 5 centimeters by 5 centimeters for each pupil in the class. After a few cuts, Asha wonders whether one tray of cake is enough for all her classmates or will she need to bake another tray of cake. Let's find out. What do we need to do first? Yes, we need to find the volume of the cake first. What is the volume of the cake? Good. We need to multiply the length, the height, and the breadth of the tray. Multiply 15 centimeter by 25 centimeter by 5 centimeter. We get 1,875 cubic centimeters. What do we need to do next? Yes, find the volume of one piece of cake. We multiply 5 centimeter by 5 centimeter by 5 centimeter equals 125 cubic centimeters. There are 30 pupils in Asha's class. In order for each of them to get a piece of chocolate cake, we need to find the total volume of cake needed for 30 pupils. Multiply the volume of one piece of cake by 30. 30 into 125 cubic centimeters equals 3,750 cubic centimeters. So, Asha has to bake a total volume of 3,750 cubic centimeters of chocolate cake. Is one tray of cake enough for all her classmates? The volume of one tray of cake is 1,875 cubic centimeters. This value is less than the total volume of cake needed for 30 pupils. So, one tray of cake is not enough to cut into 30 pieces of smaller portions. Asha has to bake another tray of chocolate cake so that all her friends can taste the delicious chocolate cake. What is the volume of 2 trays of chocolate cake? Good. Doubling 1,875 cubic centimeters, we get 3,750 cubic centimeters. So, 2 trays of chocolate cake are enough for Asha's classmates. Let us first gather some information. This monument consists of a cube and two cuboids. On the top is the cube, and at the bottom is the big cuboid. How do we find the volume of this monument? What do we need to do first? We need to find the volume of each 3D shape first. Let's begin by finding the volume of the cube. This cube measures 1 meter in height, 1 meter in length, and 1 meter in breadth. So the volume of the cube is 1 cubic centimeter. Now how about the small cuboid? This cuboid measures 2 meters in length, 1 meter in breadth, and 2 meters in height. Multiplying 2 meters by 1 meter by 2 meters, we get 4 cubic meters. Now what is the volume of the big cuboid? Try to calculate mentally. 4 meters into 2 meters into 3 meters equals 24 cubic meters. Now, do we have enough information to find the total volume of the monument? Yes, we have the volume of the cube, which is 1 cubic meter. The volume of the small cuboid is 4 cubic meters. And the volume of the big cuboid is 24 cubic meters. We add all these values. Adding 1 cubic meter with 4 cubic meters with 24 cubic meters, we get 29 cubic meters. So, the volume of the monument is 29 cubic meters. The diagram shows a pillar. Find the volume of cement used to build the pillar in cubic centimeters. How do we solve this problem? How many 3D shapes are there in the figure? Yes, this composite shape consists of 2 cuboids and a cube. Let's find the volume of the cube first. What is the dimension of this cube? Yes, it is 60 centimeter by 60 centimeter by 60 centimeters. What is the volume of this cube? Good, it is 216,000 cubic centimeters. Now how about this vertical cuboid? It measures 50 centimeters by 50 centimeters by 200 centimeters. So its volume is 500,000 cubic centimeters. Calculate the volume of this cuboid. It measures 80 centimeters by 80 centimeters by 40 centimeters. Multiply these values, we get 256,000 cubic centimeters. Now, do we have enough information to find the volume of the pillar? Yes, we have the volume of the cube, which is 216,000 cubic centimeters. The volume of the vertical cuboid is 500,000 cubic centimeters, and the volume of the big cuboid is 256,000 cubic centimeters. We add all these values. Adding 216,000 cubic centimeters with 500,000 cubic centimeters with 256,000 cubic centimeters, we get 972,000 cubic centimeters. So, the volume of cement used to build the pillar is 972,000 cubic centimeters. Let us gather some information from the problem. The volume of the wooden bench is 69,600 cubic centimeters. The top surface of the bench is to be painted yellow. So we need to find the area of the top surface. To find the area of the top surface, we need to know the length of this rectangular shape. How do we solve the problem with these given values? Let's label this composite shape first for easier identification. A is the large cuboid. B and C are identical cuboids. Let's begin by finding the volume of the two identical cuboids B and C, since the values given are enough. Calculate the volume of one cuboid first. Remember to calculate the volume of a cuboid. We multiply its length by its breadth and its height. 10 centimeters into 10 centimeter into 60 centimeters equals 6,000 cubic centimeters. What is the volume of the two identical cuboids? Doubling 6,000 cubic centimeters, we get 12,000 cubic centimeters. Now we have the volume of two identical cuboids B and C, and the volume of the wooden bench 69,600 cubic centimeters. What do we need to do next? Good. From this information, we can find the volume of cuboid A by subtracting the volume of the two identical cuboids from the volume of the wooden bench. 69,600 cubic centimeters minus 1,000 cubic centimeters equals 57,600 cubic centimeters. So, the volume of cuboid A is 57,600 cubic centimeters. Now, from this information, how do we find the area of the top surface? Yes, we need to find the length first. The volume of cuboid A is the length by breadth by height. Let's fill in the formula with the information we have. 57,600 cubic centimeters equals length times 60 centimeters times 8 centimeters. Let's rearrange the operations. To find the length, we divide the volume with the breadth and the height. 57,600 cubic centimeters divided by 480 square centimeters. Or we can divide the volume by 60 centimeters first and then divide by 8 centimeters. We get 120 centimeters. When we divide the unit of cubic centimeters by square centimeters, we will get centimeter. So the length of cuboid A is 120 centimeters. Now what is the area to be painted? Area of the surface is the length times the breadth. 120 centimeters into 60 centimeters equals 7,200 square centimeters. So the surface area of the bench to be painted is 7,200 square centimeters. Let's look at another problem involving calculations of volumes of 3D shapes. The diagram shows a container in a shape of a cuboid that contains water. The base area of the container is 18 square centimeters. The volume of water in the container is equal to the volume of cube with sides 6 centimeters. Find the height of water in the container. How do we solve this problem? What do we need to do first? Let's begin by finding the volume of water first. Given the volume of water in the container is equal to the volume of cube with sides 6 centimeters. What is the volume of cube with sides 6 centimeters? 6 centimeter into 6 centimeter into 6 centimeters equals 216 cubic centimeters. So, the volume of water in the container is 216 cubic centimeters. Given that the base area of the container is 18 square centimeters, area is length multiplied by breadth. So, the formula for the volume of water in a container is base area of the container into the height of the water. To find the height of water, divide the volume of water by the base area of the container. 216 cubic centimeters divided by 18 square centimeters equals 12 centimeters. So the height of water in the container is 12 centimeters. Now what if we want to fill the container completely with water? Given that the volume of water in the container is 216 cubic centimeters. The base area of the container is 18 square centimeters and its height is 38 centimeters. What is the volume in cubic centimeters of water needed to fill the container completely? How do we solve this problem? What do we need to find? Good. To find the volume of water needed to fill the container completely, we need to calculate the amount of empty spaces that the volume of water will take up in the container. Let's begin by finding the volume of the container first. Given that the base area of the container is 18 square centimeters and its height is 38 centimeters, multiply 18 square centimeters by 38 centimeters. We get 684 cubic centimeters. So, the volume of the container is 684 cubic centimeters. Now, how do we find the volume of water needed to fill the container completely? Good. We subtract the volume of water in the container from the volume of the container. 684 cubic centimeters minus 216 cubic centimeters equals 468 cubic centimeters. So the volume of water needed to fill the container completely is 468 cubic centimeters. Summary. Let's summarize the topic. Amount of region occupied by a solid is called its volume. Volume of a cuboid is equal to L into B into H. Volume of a cube is equal to L cube, where L is the length of one side. Volume of a cylinder is equal to pi into r squared H. 1 centimeter cubed is equal to 1 milliliter. 1 liter is equal to 1000 centimeter cube. 1 meter cube is equal to 1 lakh centimeter cubed, which is equal to 1000 liters. Let's stretch your mind. Box Y is a cube of the same height of cuboid X. How many identical boxes X can be put into box Y?